Hello and welcome to part 6 of my residential network cabling series of videos. I'm Ron with IDEAL, and in this portion of it, I'm going to talk about actually UTP cable testing. So we'll talk all about the different things we actually test that category wire for, and talk a little bit about what you ought to know when you go out and buy test equipment too. Okay, and we'll just get right into it here. And when you're testing cabling in buildings, one of the first things you're taught as an installer is to visually look at what you just did. You can a lot of times spot miswires and things like that. But if your heart is set on doing some testing on this cabling, well, then you got some choices to make. And in the industry today, we have 3 levels of test equipment you can go out and buy. There are what are called verification testers, and they're also referred to as wire mappers, and they're just going to look for basic continuity in the cabling, and they're the roughly $50 to roughly $400 in the U.S. is what they'll probably cost you, depending on what they do. And for a lot of guys, that's all you need right there. And now, the problem with them is you can't print anything off them. So if you need a tester that you can actually test a cable and then actually print something off of, well, the next level up are what are called qualification testers. And I'm going to say they're fairly new in the last 5 to 7, 8 years or something like that. We're beginning to really see them take over a lot of the testing that's being done out there. And qualification testers, depending on who's you buy and what they do, will run you roughly $1,200 to roughly $2,200, again, US. Okay? Now, if the customer is asking you to actually certify your cabling and they're asking you to make sure it is compliant with Cat 6A or 6 or whatever one of the standards is, well, then you need to go out and invest in what are called certification testers. Now, there's not a lot of people making them anymore, and they're not cheap. I mean, you're going to invest $6,000 to $8,000 in a copper version, and they're going to go up from there. And really, you got to send them in annually to get calibrated by the factory. So they're a lot of money, is what they are. So we'll take a look at each of these and give you an idea of what they actually do and what might be the one you want to buy. Now, as I said earlier, verification testers are kind of the bottom of the rung, and when you buy them, you can buy them that just do basic UTP testing, and they're going to look for 568A or 568B wiring in a building or in a cable. Or you can buy the little more expensive ones, and they're a basic category tester for, again, Category 5 Cat 6 wire. They also do basic coax testing, looking for just opens and shorts and coax. And they might also do phone testing. And again, they're going to look for USOC wiring and phone circuits. And they might actually have another couple features to them, but that's kind of for a lot of guys, that's what I probably would recommend for folks. And the more expensive versions of this, one nice thing they'll have is they'll have extra remotes. So with a lot of these testers that only give you one remote, you got to put that remote at an outlet in a room someplace, run down to where the panel is or the other end of that cable is, and actually go find and test that cable. And then you got to run upstairs and move that remote to the next outlet. So it's a little bit of workout. And the ones that are more in the $400 range are going to come usually with about 8 remotes, and you can test through the remotes. And that way you can put all 8 remotes in a building and then run downstairs and identify each one separately back in a panel. And the more expensive ones will normally test length as well. Have a couple different ways of doing that. And they might blink a hub or something like that too. But that's kind of what you're looking at in that verification tester kind of group of test equipment, okay? Now, the next rung up the ladder from that are what are called qualification testers. And the SignalTech 2 tester from IDEAL is a great example of one of those. And I would refer you to the video on that if you want to learn more about that particular tester. And it's interesting. For many, many years, there was no such thing as qualification testers, and all we had were certification testers, and they tested cable to a certain standard, like Cat 6 or 6A. Now, that standard supports lots of different applications, but you know what? Ethernet today, when it talk about data networking, is really king. And so in many cases, all we want to know is that data network going to work. And well, these are essentially Ethernet testers at a minimum, I should say. They will do a lot of things besides just Ethernet. So they will test for 1,000 base T cable, and they will actually simulate 1,000 base T Ethernet system across a cable link for you here, and actually tell you if that cable will support a gigabit Ethernet. If it didn't, it would retest the cable at 100 base T and actually tell you what the cable was capable of supporting. Now, in many cases, these can also be used on live circuits and networks and identify IP addresses, PoE for Power over Ethernet, Voice over IP. They might be able to simulate things like cameras and things like that. So there's a lot of other things that these qualification testers might be able to do for you. And again, they're going to run you roughly $1,200 to roughly $2,200, depending on who's you buy and what it actually does. But as I said, go check out the new Signal Tech 2 from IDEAL. It's a pretty nice one. And those are qualification testers. Now, one nice thing about them is you can generate a report off of them at the end of the day. And so if your customer is just looking for some form of report, and you generally don't need a separate laptop or something, you can a lot of times download right off these things. And so that's very handy to have, okay? Now, the next rung on the ladder from that, of course, are certification testers. So, again, if the customer is telling you need to certify your cabling, this is what they're referring to. And not certified it to Ethernet, but certify it to a TIA standard like Cat 6 or Cat 6A cabling. And these are a lot more money, and they're going to do a lot of high-end, high-frequency type tests that are kind of expensive to run. Normally, you're not going to find this in residential. Not many homeowners would ever pay for that level of testing. So maybe one of the other testers would be just fine. And these are testers that I'm not going to hand to just anybody, and usually done at the end of the project, just to be sure that we've got that cable installed properly and we've got some documentation to prove it. And a lot of folks, a lot of times, like to go ahead and test their cabling, especially if they can save results. Because if you come back in 6 months or a year and they want you to warranty something, maybe you can actually pull out the test results of that cable when you installed it and compare it to what might be happening today, and hopefully maybe it'll decide what possibly might have been wrong in the last year or so that you've been gone. So certification testers, I'm going to say, unless you're made to do that, more than likely you're probably not going to go to that expense today, especially in residential. But in commercial work, you'll definitely run into it, okay? Now, what do all these testers test? And, well, a certification tester is going to measure everything you see here on the screen. And the qualification tester will do the wire map, it'll do the length, it'll do the propagation, the delay, and delay skew here. And it will, again, test the cable to Ethernet, which certification testers do not do. And a verification tester might only do the first one on this list, which is a wire map. So let's take a look at all these different things we're actually measuring here in the cable. Now, wire map testing is the minimum we would expect you to do. And a lot of the $50 versions of these testers, that's what they're going to do. And they're going to look for basic opens in cabling. They're going to look for shorts in cabling. Reversals, we're going to have a pair, obviously reversed. A miswire over here, and the miswire on the screen here is the orange and green has been flipped here, which is usually telling me someone's wired 568A on one side and 568B on the other and caused that miswire. And when we see other miswires, that's usually people who aren't seeing colors too good, and especially with plenum wire, with the compound that makes it plenum, doesn't hold ink real well. So again, blue can look a lot like green. So. And then that last one is called a split pair. And in this particular split pair, what they're doing is they're sending a signal down the white-green conductor, and they're sending the other half of that signal down the blue conductor. Now, the two conductors are not twisted together, so can they eliminate noise and crosstalk in that pair? And, of course, they can't. And so there's a test where we're actually testing to make sure that the signal being sent down a pair is sent down a pair that's actually twisted together. So those are the 5 basic things you've got to go out and measure. Now, you can go out and find some very inexpensive $25 versions of wire map testers, and you'll find out they don't do split pair testing, which I don't even know why you would want to buy a tester that doesn't do all the tests, but be careful out there. You might run across those. So those are the minimum you should be able to do with your tester, okay, for your category wire. Now, when we test length in cable, you got to understand it's not the physical length of the wire, it's the electrical length of the wire. Because typically when you go out and buy cabling today, every 2 feet it's marked physically how long it is, and it'll tell you, that way you know how much of a 1,000-foot box you've used because it counts down from 1,000. And this is never a problem until we get to the 90-meter rule or the 100-meter rule on category wiring. Where 90 meters in the wall, 10 meters outside the wall, so the total channel can be which is both, can be up to 100 meters in length. Now, when you look at the construction of the cabling, obviously we twist the pairs. The cable is longer than the physical length. So when you look at things like Cat5e cable, depending on who it is and who made it and how much twisting they're doing in the pairs, I want to say 5 or 6, maybe 7% difference between the physical and the electrical. So a 100-foot length of cables might be more like 106 feet inside, depending on the pair. Cat6 cable, since it's twisted even more, will be maybe 8 to 10% difference. And Cat6A, which is really, really twisted, it'd be even more than that. So again, never have to be. It's never really a huge problem until we get close to the 90-meter rule in the walls. Okay. Now, when we look at testing what we call the delay and the delay skew, and we actually measure the time it takes the electrons to travel down the cable. Because in gigabit Ethernet, it's what we call full duplex, and we're using all 4 pairs in a cable, and we're sending signals in both directions at the same time, and it's called full duplex. And again, we're using all 4 pairs. Well, we will put part of that signal down each of the pairs separately, and when they all get on the other end, we've got to reconstruct them. And if they don't all get over to the other end within a certain time frame, we can't put the packet back together, and so it would drop the packet. So it's called delay, and the differences between the fastest and the slowest pair is what we call the delay skew. Now here's an example where we're looking at the delay and skew in a particular cable, and you'll find that not always, but blue is almost always twisted the most, so it's usually the longest pair in a cable. Brown is usually twisted the least, but again, not always, so it's usually the shortest cable in a lot of category wires. So you see the blue pair here is at 100 nanoseconds of delay, and the brown is at 75 seconds, nanoseconds of delay, and obviously the difference between is 25 nanoseconds. Now, gigabit Ethernet will allow us up to a max of 50 nanoseconds of delay between the fastest and the slowest, or for our skew, I should say. So just one more parameter we measure in the cable. And nanoseconds, if you don't know, that's a billionth of a second, so it's shooting right down that cable. One of the key parameters we measure in cabling is called nearing crosstalk. And essentially, crosstalk is noise between pairs in cable. And if we inject a signal at the near end of a cable and look to see what that does to other pairs at the near end, where that signal is usually the strongest in the cable, we will actually induce, like I say, a signal into one of the pairs and see what is coupled into the other pairs nearby it. Okay, and they call that nearing crosstalk. And if you were to be able to look at a plot, excuse me, on a certification tester that would actually look at the nearing crosstalk in a cable, it would look like the plot you see here on the chart. Now, across the top of that chart, we're going from 0 megahertz up to 250 megahertz, which is for category 6 wire. And we're going from 0 down to 100 decibels of signal strength. And with any of the crosstalks we run across, we want as high a dB in number as possible. And this is actually a representation of how resistive the circuit is to noise. So at very low frequencies, that number is very high. And the red line there is the go-no-go line, and the squiggly little lines underneath that red line are all the different plots the tester has made on each of the different pairs. And if any of those plots happen to touch that red line at a certain frequency, it would actually fail the test. So as big a number as possible, and as is better here. And as frequency goes up, the noise floor will come up, and so the circuit gets more and more susceptible to noise as the frequency goes up. Okay. Well, if you're guessing what we would call it on the far end of the cabling, if we're going to look at this crosstalk, we would call it far end crosstalk if you haven't figured that out by now. And it's essentially the same type of test, so it's only being done at the far end of the cabling. Now, we used to call another one called ELFEXT. It is now referred to as attenuation crosstalk at the far end, okay? And essentially, when you look at the effects in a cable, part of the effect of what the signal strength is at the end of the cable is the actual attenuation in the pairs themselves. Now, kind of to take that out so it's more, again, equal level, the attenuation crosstalk ratio far end is basically the far end crosstalk minus the attenuation in the cabling. And so it's just one more parameter we're going to measure in that, and we will actually take a look at the attenuation and crosstalk ratio between the two as well. And you're going to get a very similar plot on your certification tester, where again the bigger the dB number is a representation of good. Okay, so that again the circuit is more resistive to noise the bigger that number is. Right now, when gigabit Ethernet becomes pretty standard in the industry many years ago, and we start transmitting on all 4 pairs, another parameter we ended up starting to test for is called power sum near-in crosstalk and far-in crosstalk. And essentially what we're looking at here now is, instead of injecting a signal on one of the pairs and see what that does to another one of the pairs within the cabling, and again in gigabit Ethernet we're using all 4 pairs, we will inject a signal on all three of the pairs out of the 4 and see what it does to the 4th pair. And they will do that on all 4 pairs. And the tester will do it this way down the cable and spins around and does it this way down the cable, so again both directions. And that's like 24 little measurements that a certification tester is going to make just on that power sum crosstalk measurements that we will be making in the cable. So there's another parameter that we measure that when 10 base T was king we wouldn't have. Okay. Now we obviously will look at attenuation in cable and see what the signal loss is in the cables as well. And most of the attenuation is really in the cable itself, not so much in the connectivity, but it can manifest itself there as well. And especially if you use poor connections, or you're using Cat5e jacks on Cat6 cable, or you're using Cat6 patch cords on Cat6A cable, things that aren't matching there, so to speak, can affect the attenuation in the cable. And the attenuation is really the opposite of the crosstalk in the cabling. And it's a representation of what the loss in the cable actually is. So in this case here, you see a kind of a similar plot, but in this kind of across the top of the chart was frequency again. And we're going out to 250 megahertz, or again Cat6. The attenuation is on the side, measured in dBs from 0 out to 50 here. And you can see as the frequency goes up, the signal drops off and we lose more and more signal. So the lower the dB number here in attenuation is actually better. So it's, again, the opposite of the crosstalk. So the red line is the go, no-go line here, and the individual plots of the individual pairs is above that line. And again, if any of the pairs pass the red line, it would end up actually failing the test. So, and again, this is only actually done in one direction only. So that's the attenuation in the cabling. And then we'll actually compare the two and do what they call the attenuation to crosstalk ratio. And if you want to think of this as signal to noise ratio, it is, only that in signal to noise, we're worried about what outside interference is doing to the cable. And in here, we're talking about what's going on within the cable jacket itself. And so we actually can plot both those on one of our certification testers, can plot this for you. And as you can see, the attenuation's on the top half the plot. The crosstalk, near-in crosstalk, is on the bottom half of the plot. And you'll see it has kind of a funnel effect here. And depending on if it's Cat5e, Cat6, Cat6a, the difference between the two is referred to as headroom. And the bigger that gap in that funnel, the better the circuit is to being resistant to noise and have a good clean signal. So here we want that gap to be as big as possible. And again, the certification testers can plot this on all the pairs for you individually, and again store thousands of results in the process. Okay. Now, another fairly important parameter we're going to measure in the cabling is what's referred to as a characteristic impedance in the cabling. And, you know, when you and I look at a particular cable, and again, the impedance is kind of referred to as the total opposition of flow of conductors or signals through a particular conductor or cable. And, you know, when you and I look at two wires that are twisted together, we see two wires that are twisted together. Electrons traveling down this cable are going to see a series of inductance and capacitance and resistance here. And the three of those make up the total opposition to the flow of the signal through the cable. And so the resistive reactance in the cabling, as a general rule, as an installer, you're not probably going to affect this as long as you don't change the gauge of the cable and you pulled on it so hard that 24 gauge wire became, you know, 26 gauge or something like that. Inductive reactance, I've kind of mentioned it before, is we no longer like to coil a bunch of cables up above like a drop ceiling or something like that. So, you know, so if later on down the road we need to move a furniture, we have plenty of slack up there. And the reason is because as frequency goes up, we coil more and more of those cables. We change what's called the inductive reactance in the cabling. Now, of the three of these things, capacity reactance is the biggest of the three. And if you don't know what capacitance is, when you put two conductors side by side like this in a circuit, they will build an electrical charge between them. And we change that gap between those two conductors. We're going to change what's referred to as the capacitance in the cabling as well. So as long as you don't untwist a bunch of cables or pairs, you should not affect what we call the capacity reactance. But the three of them are what make up the total impedance of this particular cable we have. Now, what's interesting about UTP cable is that, or catenary wire, is that the specifications for it is to be 100 ohms, and again, all the devices that plug into it are designed to be around 100 ohms of impedance. But we've built into that system 100 ohms plus or minus 15%. So you technically could have a cable at 85 ohms here in this picture. You have a jack at 104 ohms and a patch cord at 114 ohms. Now, all of those are within that specification of 100 ohms plus or minus 15%. Now, we obviously don't want big differences in all these impedances so we can avoid it, because most of the energy goes past this, so to speak, bump in the road. But some of it will get reflected back at you. And that's what we call return loss in cabling. And it's interesting that when they developed a cabling system for Ethernet, again, they wanted a rock-solid tank. And one of the reasons you can knot cabling and kink it, and a lot of times it's working fine, especially with 10 and 100 base T, is because of this 100 ohm plus or minus 15%. But a lot of times when I see a cable fail certain things, like return loss, I can almost always tell you that's somebody who's probably twisted too much of a pair in a cable, and we can start looking for usually bad connections that have caused that. But that's, again, just one more parameter we're measuring in the cable, and again, we're looking at this reflected energy that is coming back because of these impedance mismatches, and again, we call it return loss in a cable. Okay. Now, as you may have noticed in my last segment, I'm talking about the different types of UTP type cables that are out there. Again, we've gone from Cat 5 to 5E to 6 to 6A and on to Cat 8 maybe in the future. And as we get above 300 megahertz, into the 500 megahertz range, which is where Cat 6 is, we're beginning to run into some other things that we're going to look at. And one of them is alien crosstalk, which I may have probably mentioned before. And the other problem we're running into is the RJ45 connectors are beginning to have more and more problems. And so as we move beyond 500 megahertz, are we going to change the old RJ45 formatted connector? And the answer is probably, there'll be probably a backward compatible version of it. Might still have to use new adapters for these new cables that come out for Cat 8 that comes out. But we're running into some more problems. So alien crosstalk is a new parameter that was never thought of before. And so when we get into Cat 6A and 6, we were beginning to look at this other thing here. And alien crosstalk, we've always been more concerned about what's going on with inside the cable, not necessarily what's going on outside of that cable. And it's interesting. They don't tell us how to measure for this as a general. As a tester manufacturer, they don't tell you how to measure for it or how to build a tester for it. They just tell us another thing to go look for. And you'll basically never do 100% alien crosstalk testing in a cable, because you would have to go out and look at all the different combinations of what the one cable, what this bundle is doing to the one cable in the middle of the bundle. And so we're always worried about what's going on within the cable, the cable itself. But with alien crosstalk, we're now beginning to look at what that bundle is doing to the cable in the middle. So they will pick what are called disturber cables, or victim pairs, I should say, and they'll normally pick like 6 disturbers. So they'll look, when they do their certification testing in this building, they will pick usually some 5 short runs, 5 long runs, and 5 medium runs, and maybe start doing some alien crosstalk testing. And depending on the certification tester you have, it might do it a couple different ways, but take a look at those certifiers to figure out how they go about doing this. But it is just one more parameter we're beginning to look at. And it's interesting. We've always liked to make sure our bundles are nice and tight and look really good. And today's with alien crosstalk and 10 gigabit applications, we're beginning to actually tell you to loosen up the bundles a little bit. So, as I said, though, you're virtually never going to do 100% testing on this, but it is one more parameter that you could start looking for in a building if you're running into problem as we get into the 10 gigabit applications that are out there. Now, the question would be is if you're making this migration from Cat 6 to Cat 6A and maybe beyond, will your existing cable infrastructure support 10 gig applications that Cat 6A is meant to support? Well, the answer to that is it probably is. Your Cat 6 solution in your existing building will probably support 10 gigabit applications, but the question is at what distance? And so you almost have to actually go try it. And we like to tell you that, at under about 40 meters, it's probably going to work without any problems. But beyond that, you're going to start doing some testing. Yeah, and if you do run into problems, well, maybe you put Cat 6A jacks on those Cat 6 cables, or you use, again, Cat 6A patch cords to help increase this. But Cat 6A cable should support 10 gigabit applications all the way out to the 100-meter rule. So, but the question always is the existing cable, can we squeeze a little bit more out of the existing cable in buildings, which building owners typically like to do because it's rewiring a building, it can get pretty expensive. So, again, you might look at of changing out some of the jacks to Cat 6A and things like that in order to help mitigate this whole problem. Replace the Cat 6 patch cords with 6A patch cords. But you'll have to do some testing in the cable infrastructure to actually find out will your existing Cat 6 cable support, again, 10 gigabit applications. And again, alien crosstalk might be one more of those new things you might be looking for. Now, a new cable coming out to us in maybe the next 1 to 2 years is what we refer to as Cat 8. And the industry is beginning to talk about what frequencies and distances Cat 8 cabling was going to support. Now, Cat 8 is designed to support the next rung up the ladder on Ethernet, which is going to be 40 gigabit applications. So we're going to jump from 6A and 10 gigabit applications all the way up to 40 and probably beyond. And the frequency range the guys are beginning to look at is all the way out to 200 megahertz in frequency. And Cat 6A is supported out to 500 megahertz. So we're going to have a 4-time increase in that bandwidth. And so what other things are going to happen that we're going to have to measure for that we don't measure today? The answer is I don't know. And I think the industry is in the process of finding all that out. Now, I'm hearing they're going to limit the 40 gigabit applications to 50 meters, but they might change that too. And they're going to have 2 classifications of Cat 8 cable, and what they call Class 1 and Class 2. And Class 1 versions of it will support the old RJ45 formatted connectors. But the Class 2 stuff is going to start utilizing some newer connectors you'll find in the market, such as these Terra GG45s and this ARJ45 connectors. So these are different looking connectors. They kind of look like a typical RJ45, but they're not. So Cat 8 cable, who knows what we'll be testing for in that cabling that we don't do today, but they'll figure that out sometime in the next year or two. All right. Hey, thanks for watching the channel, folks. I really do appreciate it. And if you haven't subscribed to my channel, please do. And thanks for watching. I really do appreciate it. I'm Ron with IDEAL. I'll plan on seeing you on the next one.